Okay, guys, here's where this starts to get interesting and a little trickier. So what we're going to do today is I'm going to give you a trig ratio of a triangle, and you are going to find a different trig ratio using the information. Okay, so if you've ever seen a Sudoku, which is like those number puzzles in newspapers, it's kind of like that. The logic is a little bit different than like your math logic that you use like when you're doing algebra, for example. So I want to talk about the two facts we're going to use that I want you to keep in mind. And then we'll do a couple and we'll see what this looks like. Okay, so here are the two facts. Okay, here are our two facts. The first fact is that if I know two sides of a right triangle, I know the third. Okay, so we know, nice right triangle, right? We know that if I have A, B, and C, we know that the relationship is Pythagorean theorem, A squared plus B squared equals C squared. So it's trivial if I give you two sides to know what the other side of a right triangle is. You just have to do a little bit of arithmetic, right? And then the second fact, fact number 2, is that trig ratios are talking about the relationship between two sides, right? So given a trig ratio, you know something about two sides already, and if you know two sides, you know the third, is the logic here. Okay, make sure you have your notes about trig functions handy. You're going to need them. So you're going to need to know what sine, cosine, and tangent are, SOHCAHTOA, and you're going to need to know about cosecant, secant, and cotangent as well, so the reciprocal functions. So make sure you have your notes from the last couple lessons handy as you do these. They will help you a lot. Okay, so here is what a problem from this lesson will look like. So given cotangent of A equals 8 over 15, and that angle A is in quadrant 1, you can just ignore that angle A is in quadrant 1 for now. That's talking about quadrant 1 on a graph. And one way I can make this more complicated for you in the future is to have positive and negative side lengths, but we're not going to worry about that right now. So just ignore that part of it. Find the exact value of cosine A in simplest radical form using a rational denominator. Okay, so here we go. I'm going to draw a triangle, right triangle. And then I'm going to label an angle A. Again, nice right triangle. So angle A, I'll put as the bottom right here. It doesn't matter. You just can't make angle A the 90-degree angle, right? Find the exact value of cosine of A in simplest radical form. Okay, well, let's start with what we know. So cotangent of A is 8 over 15. Cotangent is also adjacent over opposite, right? Because it's the reciprocal of tangent. Adjacent over opposite. Well, adjacent, opposite. I'm going to label that, right? So adjacent is 8. Opposite side is 15. Okay. Now I need cosine of A. This is already looking easier, right? Cosine of A is going to be adjacent over hypotenuse. So I need to find my hypotenuse, right? Let's call that H. I know everything about this triangle except for the hypotenuse, but fact number 1 here, right? I know how to find the hypotenuse too. So I'll say H squared equals 15 squared plus 8 squared. And I put H squared by itself because it's the hypotenuse, right? So it is C. And then I just do that math. So, and that gives us 289. Okay. So H squared is 289. That means H is the square root of 289. So 89. And I'll just leave it like that for now. Notice we're going to have to simplify that a little bit later. Okay, so there's my H. I found my missing side. Cosine of A then is going to be 8 over the square root of 289. Okay, so we're pretty much done. We found what we need to find. We just need to simplify now. And then as I look to simplify this, I'm realizing 289 is a perfect square. So square root of 289 is just 17. So this ends up being 8 over 17. And I'm done. So that's it. That's how we're finding these trig ratios given another. So your steps here, I guess I'll give you steps at the end. But your steps is to draw the triangle, label based on what you're given, find the missing side, and then find your ratio. Okay, we'll do one more example like this. All right. So here, same thing, different trig ratios. First step is going to be to draw our triangle. So we have sine A is equal to 3 over square root of 73. And notice like they have this ugly non-rationalized fraction for us, but that's actually going to help us. Angle A is in quadrant 1. We're going to disregard. Find the exact value of tangent A in simplest radical form. Okay, so I'm going to make A this bottom right angle again. Again, it doesn't matter which angle you make it. If you prefer to make it the top, that's fine. Your just labels are going to look a little different than mine, right? So I have sine A equals 3 over square root 73. And that means sine is opposite over hypotenuse, right? So katoa. So opposite is here, 3. Hypotenuse is square root 73. Okay. We want tangent A. We're going to use Pythagorean theorem here. This time, though, Pythagorean theorem, remember we have the hypotenuse now, so it's going to look a little bit different than the last time. So make sure you set these up correctly, depending on which sides you have. So 3 squared plus, I'm going to call this A for adjacent, 3 squared plus A squared equals root 73 squared, because that's our hypotenuse now. Okay. Now, 9 plus A squared equals, this is a common error I see, square root and squared cancel out. Okay, so you don't have to do anything with that other than drop the square root. Alright, that worked out nicely. So A is 8. And then if we want, let's go back up and figure out what we're looking for. We want tangent of A. So tangent of A equals opposite over adjacent, which is 3 over 8. Okay. So this is all about logic. You can follow a set of logical steps and you can figure these out every time. Okay, so make sure you capture at least one of these examples in your notes before you move on, and then I've written out the steps for you here. So your steps, let's see if I make this a little bit bigger for you guys. Nope. There we go. So your steps are draw my right triangle, label the sides based on the given ratio. So I turn sine of A into side lengths, root 73 and 3. Use Pythagorean theorem to find the missing sides. So that's how I got 8. And then I use that to find the unknown ratio. So if I want tangent of A, it's going to be opposite over adjacent.